Okay, folks, welcome to another session on Java. Suitably hard rock music to keep us going to, yeah. So, happy appropriate, Java Highway to Hell. Okay, so we're going to start again now. We are going to start on walking. Okay, so now the last lesson I showed you with, I'm sorry I can't make these lessons any longer. It's just that when I'm home here, there's always something. Noel, do this. Noel, do that. All right, so it's really getting difficult to get enough time to do these things. All right, so hopefully I'll be able to do more in the future, but today is going to be another short lesson. All right, so you're looking after people, you know. Anyway, but where were we? Yeah, so we're talking about walking. Okay, so walking a directory. So we explained what walking a directory was basically searching for a file. All right, searching for files. All right. Now, walk, it's a method of the files class, that's in NIO.2. And what it does is it creates a stream of paths. All right. So, for instance here, files walk path. Now, what path is that? That is C original. All right. So, go to this one here. So what I did was here I create a stream of paths. I call it P streams. Files.walk path, that creates a stream of all the paths that are contained within C original, including C original. So to print them all out. Okay, so we can see here all files and directories. Prints them all out. So stream path files.walk path, p stream for each. So that's the for each method that takes a consumer object. Okay. Walk takes, now it can take, there is 3 overloaded methods. One of them just takes a path. Another one takes something called a file visit option, which we'll be doing today. Another one takes the depth, which we'll be doing in a minute. Okay, so this one here, I'll bring up the pen, annotate. Okay, so this here creates a stream of paths. This is going to print off all of our paths, which is all of the files and directories inside C original. So we can see them all here, all the way down here. I have a lot of shit in it. Okay, Grant. You can also, so that means when you've got a stream of paths, you can call all the methods of the path class. So a files.walk path, that produces a stream of paths. Then I map takes a function object. Okay. Map, yeah, just to make sure. Yeah, takes a function object. So it means it takes in an object and it returns an object. They can be the same or they can be different. So map takes in a path and it returns that path represented as a string. Okay, so for instance, if we have a path, this path here, it's going to convert it to a string. All right, then we call the collect method. The collect method takes a, just forgot a lot of these. I shouldn't really. So map takes a function. Collect takes a collector object. Okay, so collectors to set, that puts all of the strings into a set and assigned to set paths. All right, So the amount of objects in C original is set paths dot size -1. We say -1 because C original is also included in it. All right. Now, so we can use, take out this guy. We can take out all, we can use filters. All right. So we can use all of the methods of the stream class. Now, not input streams, the other type of streams. What are they called again? I don't know what the other types of streams are called. Okay. Not the input streams, the Java 8 streams. Okay. Input streams is getting an input and output. Whereas Java 8 streams, they create things, create objects. All right. So files.walk path creates. So filter. We're only going to, so it takes in a path. Okay. So filter takes a predicate. So takes in an object. In this case, it's going to be a path. And it's going to return true or false. Now, files is directory. So this will only return the directories that are contained within C original. So you can see them here, C original, C copy town, C original country, C original country county, so on and so forth. Okay. Now, we want to get all the files in C original. Right. Now, we want to get symbolic files, exes, all types of files. All right. So if we want to get all types of files, all we have to do is find out what is not a directory. All right. So files.walk.path produces a stream of files. Then we're going to filter them out, takes in the path, and only those that are not directories. They're the only ones that are going to be included, prints them all out. So here we see all of the files. Now I have a couple of other files, JPEGs, exes. Some of those are symbolic linked files, some of them are RT files, but it'll just display all of the files. Now, you can build them up to make them more complicated. There's a stream of paths. We filter them to only have text messages. Filter takes a predicate. Okay, so what it does, it takes a predicate, so it takes in a stream. Okay, and so we go pt2 string. That changes the stream to a string. So for instance, that guy there changes that to a string. All right, and ends with .txt. Okay, so all of this returns either true or false. So for instance, for that file, that will return true. Okay, change that to a piece of text, and it checks, does the piece of text ends with the word txt. Okay, so that will be included. This one won't be included because it ends with the text jpg. Okay, just like this one here. See, original country does not end with txt, it ends with the word country. So this will only print off all of the text files. Okay, so I'm going to scroll down here. Jesus. All of the text files. Now we are going to have sorted in as well. Now sorted only works with objects that implement the comparable interface or have a natural order. Okay, numbers have natural orders, so only objects that implement the comparable interface. All right, string implements the comparable interface, so we'll sort them in alphabetical files. So there they all are: a new file, brand new, dir, link, blah blah, so on and so forth. Okay. Now, so here's all Java files. So JPath, what is JPath? Scroll up here to where JPath is. All the way up here, all the way up here. Okay, it's our application folder. All right. So JPath is our application folder. So it's the files in this folder here. Okay. Now I put in a couple of extra files inside this folder. I put in a .data file that is a serialized file from one of the sections in chapter 8. Okay, and then I put in a text file, myfile.txt. So I go files.walk jpath, and remember we're referring to this one here. Okay, that's what we're referring to. So we take in the path, we change it to a string, ends with .java. So it'll only print off examples.java and main.java. It's going to sort them. E comes before M. So it should print off examples.java and main.java. Scroll down here. There we are. Examples.java and main.java. Now scroll down a bit more here. So I want to get up that file and that file. Okay. So I only want to get these two files. I do not want to get any folders or anything that's anything in any subfolder. So we can see here I have a subfolder. So I have com.android.test folder. It is a subfolder of com.android. And inside that there's a text file and there's a myword.docx. So I do not want to find those two. So I go files.walk jpath. Jpath is source com.android. Okay, now I'm only going to go down one level. Now, one level is just what's contained within that folder. Okay, it's just what's contained in that folder. It's only going to search these 4 files. Now, if I didn't have any number in there, it would go down all the sublevels. All right, it would go down to com.android test folder. But I don't want it to do that. Okay, so it only goes to level 1. That means it will only go into source com.android. Then I'm going to filter them. Now, so this produces these 4 guys. Okay, now it will produce examples.java, main.java, backup that one, myfile.txt, com.android my folder, and com.android test folder. That's what will be produced by that. Okay, because it's only going to one level. It will not search these ones. Okay, so if I just left it like that, that would return examples.java, main.java, backup, myfile.txt, com.android my folder, com.android.test folder. Okay. Now, so what we're going to do here, so we want to get only backup.data at myfile.txt. So we want to exclude examples and main.java. Okay, so we want to exclude all files that end with the word Java. So that will take out that guy and that guy. And also we want to exclude directories. So that will take out that guy. Okay, so filter takes a predicate, takes in a path, then we change it to string. So it ends with Java, or if it's a directory, return false. So it won't be included in our streams of anymore. Okay, so it will only include backup 28 many zeros backup.data and myfile.txt. Now for each println, we can see here, ta-da, works. Okay, so whoop-de-doo. Okay, now I'm going to explain something here. Rather, I don't want to show it to you because this error can lead some systems to be locked. All right, so I'm only going to explain what these are. All right, so these are called, what you need to do is you need to avoiding circular. Okay, now I believe this error can lead to some machines locking up. Can even prevent you from turning the machine off, I think. So it's a fairly serious error. So I'm not going to do it. but I'm going to explain what it is. Okay, so all right, so let's assume we have a folder called C. Oops. All right, so I'm going to put this up on a white screen. I'll just bring up Notepad. Okay. Right. So let's say we have C. My folder. Folder A. My link.txt. Okay. Now, this is a symbolic link. Okay. So this is okay. See my folder A, my link.txt. Now this is a symbolic linked file. Now what is it linked to? It is linked to C. Change this to capital. Oops. Now, so this is linked to C, my folder. Now, so what is this? This is something called a circular path. All right. Now, if you decide to walk this directory, okay, let's say we decide to walk the directory, okay. So if we decide to walk this directory, and we're walking all of the files in it, right? So we're finding all of the files, all of the folders in this directory, all right? Now, if we walk that directory, it'll go to folder A, it'll go to my link.txt, but that links up to this folder, and then it goes down the path again. So it keeps going in and over in an unending circle. It's a circular path because this linked file links up to its parent folder, right? So if you're walking a directory and you have a symbolic link that links to its parent directory, see my folder, it's going to keep going on forever and ever, right? That's why the walk does not traverse symbolic links by default. It does not open up the links by default. Okay, so walk does not open up that file there. Okay, so by default, walk does not see that's a link and goes to see my folder. All right, now the default option is, because these are what are called link options. If you saw on the link method, you have 3 overloaded ones. You have one that can take, you have a couple of overloaded walk methods. You have one that just takes a path. You have one that takes a path and the depth you want to go. Okay. You have one that takes a path, a depth, and a link option. Now, the two of the link options, now I presume, I don't know if there's other ones, but there's 2 of them. The default link option is no follow underscore links. Okay, so if you don't provide that option, the default is it won't follow the links. However, you can change that. Okay, you can use the method that goes link option follow links. Okay, so now I'm going to type up this explanation. So don't need this guy anymore. And I'll open up my Eclipse. So I'll just copy this in to help. Now, so the walk does not traverse symbolic links by default. This can lead to directories that have nothing to do with the current directory being searched. Worse, it could lead to a cycle. Now, so the reason being, you could have a shortcut in a file. You only want to search, let's say, see my documents. Okay. Now you only want the files that are contained within inside see my documents. You could have a link inside my documents, let's say word link. You could have another one called Google link. Okay, that's a symbolic linked file, and it's linked to, let's say, C program files. Microsoft MS. This one could be linked to C Google / Chrome. Okay, you want to search in my documents. You want to get a list of all the files inside my documents. And if the walk method followed links, these two documents would come up as being inside here. Now the address would say C Google Chrome, would say C program files, but if you wanted to say how many files are inside this directory, it would say that these two files are in this directory, which wouldn't be right. All right, so by default, they don't follow symbolic links. All right, the walk method by default does not follow symbolic links. Okay, now a worse thing can happen. It could lead to a circular path. Put it in there. Okay. So as an example, we have a folder that contains a symbolic link. That one. C folder A mylink.txt. My link is linked to C my folder, which works down to mylink.txt, which links back to the root folder, and it does this infinitely. Okay. So it keeps on, I'll say it just keeps going in a circular. It's a circular path. All right. So it doesn't, by default, it doesn't follow the links. Okay, because your walk method actually looks like this. So if I go here, files dot walk, let's say a path to level 1, and then we go link. I think that's that. Let me just check, is it link option or link options? Okay. So link option dot no follow underscore links. Okay. Now this is the default behavior. So this is the default behavior in the walk method. Okay, it follows path down all the subdirectories, but will not follow any shortcuts. Because a symbolic link file is a shortcut. That's what it is. Okay. Well, technically it's not, but it's a shortcut. Okay. Not follow any shortcuts. Symbolic linked files. It finds. Okay. So you can do this. Files.walk path link option dot, and we go follow. Okay, this will follow links. Now it says it does, but I have an example here, and it's not working right. It's not doing as it should. But this is what the literature says. Now, do you ever really need to use that? I think that makes things way too complicated. If you're trying to account for what you could have hundreds, you could have literally hundreds of shortcuts in files you don't know about. So if you go follow links, Jesus, you could technically end up probably with every file in your computer. All right, so depending on which folder, for instance, program files would have links all over the place. That's program files x86. All right, so I'm going to show you an example, but the example doesn't work, but I'll show you the principle of it anyway. Okay, so I'm going to go path link is equal to paths.get. Now I have created these files already. All right, so C and I go original, and I go, actually I'll copy and paste. Right, now, so what I've done here is create two files. One file in a different directory called that. Okay, and another, a symbolic link with the name. Now, how will you create those? I'm not going to go through it again. We've done it already, but if you want to know where it is, it's in section . So refer to section 9.2, interacting with paths and files B, and how to create a symbolic link. Okay, you have to do it to command line prompt. Okay, so to create a symbolic link, you have to do it through command line prompt, number one, and number two, you have to be logged on as an administrator. Or just quickly, what I mean by that, go to here, type CMD, right click here, you click on run as administrator, you go to here, then you get this guy, then you go CDC original, there it is, and I think it's MKLINK, isn't it? Something like that. And this, so that's the link. That's the file it's linking to. Okay. Oops. I think that's it. There should be 2 seconds. 9.2b. Source. And yeah, in K link. There it is. So it's in K. Oh, shite. That's the way it is done. Now I'm not going to run it because I've already created, but that's all you have to do. Okay. So it's in K link. That is going to be the symbolic link. That's the file it's linked to. Okay. Now after I run that command, if I go to C originals, this is so you can see it here, brand new dir linked. I double click on that and it links up to brand new dir.txt. Okay, so the link is working. All right. Close off that guy. Now, so we're going to have a try block. First thing I'm going to ask is to make sure that they're linked to one another. So if you remember, how do you find out if one file is linked to the other? The command is one file linked to the other? Here I go files dot is same file. Okay, is same file, so we go link, we go file. Okay, that's how we find if they're the same links. So great. So now here is where it kind of goes tits up a small bit. We're going following links. Now, if I just go files dot walk and I just put in path. Dot sorted dot for each. Now, so what does this print off? This prints off all of the files that are contained within C original. Now, you can see new file.txt, brand new dir. So the link we're talking about is brand new dir.txt. Now you notice that C brand new dir is not coming up here, right? It's not coming up because it doesn't go to the links. So as symbolic links are not traversed by default with walk, the file, see this one here, which is linked to this one, will not appear in the stream of files or of paths. Okay, so we can see it there. It ain't there. So I'm looking for brand new dir.txt. Brand new dir.link.txt is there, right? But not brand new dir link.txt. All right, so whoop-de-doo. Now, so what we can try to do is we go files.walk path. Now, one of the options, so you can put in the amount, the depth we want. We don't really care about the depth. Now, which one is it? Let me try that one. I think option dot. Option. Let me just see. So LINK dot. Bollocks. So it's not link option. Shite. What it actually is file visit option dot follow links. Now dot sorted dot for each. Now the problem here is that this doesn't seem to work. So here see where it is. Now, so if we go up here, so follow link options. So it's the file brand new dir.txt is still not appearing. I'm not too sure why. Okay, I'm not 100% sure why. I could try changing it to 1. That's going to go to a depth level of 1. Still isn't displayed. So I'm obviously doing something wrong, but that's the principle of it anyway. Okay, the principle of it is that's how you get to follow links. Now I haven't, as I'm going to say, I don't know why it's not working. I presume it's because some sort of other permissions or something else that I haven't done right. All right. As to say, I don't know why. It just isn't working. It's as simple as that, okay? But that's the principle. That should follow that one down to that file. But it doesn't. And it should appear in here, but it doesn't. Okay? I'm not 100% sure why, but hey, what can we say? It just doesn't work. All right? So, in all honesty, it's not that important anyway. Right? I don't know why you'd want to go to yeah, I suppose it's possible you'd want to see where all the links, where all they're linked to. So you could have a file, you could have a folder that's got thousands of shortcuts in it. You want to find out simply where each shortcut lists. That could be one way of doing it. So I'd need to, might come back to that. We'll have a look to see how to get follow links working. Okay, it's not working here currently. So this is the principle. This doesn't work correctly. But principle, this should follow all symbolic links. Okay, I even have another one here. carlink.txt is linked up to car, but that's going to display anyway. So yeah, I'm not 100% sure why it isn't working. Okay, now, so I am Continuing on here, and I'm going to do static void ex2. Okay, so now this is the method called find. Okay, so find. So walking is going to display all of your files, all of your directories. Now you can filter it down by using filter. Okay, so walk can be used to search your directory, can be used to search for all text files, can be used to search for one particular file, can be used to search for one particular type of file, right? So walk can be used to do that. Now you have to use filter with that, okay? Now, instead of using filter, you can use another method, all right? So filter can be used with walk to search for a particular file, to search for a particular folder, to search for particular types of files, to search for only files, to search for any Java files, to search for any folders, so on and so forth. Okay, so now there is a particular method of the files class called find. So it's using find to search a directory. Okay, now, so this is the method. What it looks like, it is files.find, and it takes, what does it take? It takes a by predicate, so as I can remember. Okay, now it can take a path. Let me just get this right first here now. So find, usually what you put in is path, and say depth, max depth. Okay, and a by predicate. Okay, so I'll just take that guy out. And also you can put in file visit options or file options or whatever shite you want. But this is the one we use. Okay, so this is what it looks like. And okay. Okay, so it takes a path, max depth, and it takes a by predicate. Okay, now you don't have to use this one when you're searching for searching a directory. You can use walk in conjunction with the filter. All right, but this is just another way of searching a directory. So you can use filter with walk. In actual fact, I think filter with walk is actually easier. Walk followed by filter. That can be used to search for particular files or to search for a series of files or whatever. Okay, so but there is a method also called find, which the most common type takes a path, max depth, and a by predicate. By predicate, what's a by predicate? A by predicate is it takes in two objects and returns true or false. Okay. So I'll explain this guy. So okay, so Path is the path, okay, of the directory you wish to search. Max depth is the depth of the search of the directory, i.e. 1 will only be search the original and none of the subfolders. Okay. And by predicate, takes in two objects and returns true or false. Okay. Okay, so now by predicate can take in anything. All right. Now in this case, what we're trying to do is we're trying to find what files were created in the last 3 days. What files were created before 3 days ago? What files, right, so what files were created in the last 3 days? What files were created more than 3 days ago? Okay, now I've been dicking around with C originals. So before you do this, make sure that your folder C originals has files from a couple of days ago. Okay, or if it doesn't have from a couple of days ago, let's say create a file in it yesterday, do it to 1 day. And I've picked 3 days. So we're going to find all the files and folders created in the last 3 days. And we're going to find all the files and folders that have been created more than 3 days ago. Okay, just give me a second. I should pause this for a second. Back in the tape. Okay, so now, so what we're trying to do here is so first of all, what I'm trying to do, we will try and get all files and folders that were created in the last 3 days. That's my sister-in-law passing there. That's my brother's wife here. She'll be passing again in a minute. Say hello, Trish. I don't know if you can see her. Doing some of the flowers, something like that. And try and get all files and folders that are created in the last 3 days. Okay, there she goes again. So sorry, all right, we'll try and get files and folders that were created more than 3 days ago. Now, so if we know them, so that's simple enough. The files that were created more than 3 days ago, the opposite of that, then they were created less than 3 days ago. All right, now, so first thing we need to do, we need to guess whatever 3 days ago is. All right, so how we go? We go local. Now I am going to go 3 days from this particular time. So in my case, it's 4:15. So it'll be local date, time, date, time is equal to local date, time dot now dot minus days 3. Okay, so I will run that now. days ago is exactly daytime. It should be given as 1663 days. Oops, ex2. Oops. So 3 days ago is exactly 1616. So this is the 12th. Today is the 15th. So 3 days ago from that is the 12th. Okay, great. Right. So in the last 3 days. So what is this? This is exactly 72 hours ago. This is the time exactly 72 hours ago I'm running code. Alex. 72 hours, 324 is 72. Okay. 72 hours. Okay. Just to make sure no confusion is there. Now, let me just see. Now, the unfortunate thing is if you want to find out if a date is before or something like this, I'm sure there's an easier way than doing this. Right, this is the way I've done, I know. So I'm going to go long seconds is equal to daytime dot add zone. Now, this code should then work on any machine in the world. All right, doesn't matter what time zone you're in, it's going to take this into account. If we didn't have this, different time zones could be working on daylight saving times and all sorts of shit in it, or it just wouldn't work properly. Okay, so by using this guy, we are going to get. So I'll just put in what I need to put in here first. So I'll put in here zone offset system default. So this is going to get the time zone of this machine. All right, 2 epoch second. Now, so what that's going to do is amount of seconds since 1st Jan 1970 to 3 days ago is a big number, probably about 1. Okay, so that's 1, 2, 3. So it's 1.586 billion seconds. Okay, and of course that's going to go up then. 1.58. Okay, so we'll say approx. This will be approx 1.58 billion seconds. Okay. Now it's 3 days onto that. So how many seconds in? 60 seconds in an hour, or sorry, 60 seconds in a minute, 3,600 in an hour. Multiply that by 10 is 36,000. Multiply by 2 is 76,000. You're talking around 85,000 seconds in a day. Okay, so approximately 85,000 seconds in a day. In a day, 3 it's 24, 255. So you're talking about approximately 225,000 seconds in 3 days. Okay, so it's approximately 225,000 seconds in 3 days. So if we want to get the current time, you're getting approximately 225,000 more than that. All right. Now, so this is a point in time. All right. So this is a point in time. So we're going to use this point in time that anything after that was created in the last 3 days. Okay. Now, I know, for instance, that what have I created in the last 3 days in C original? Okay. Let's go back to here. I know I created carlink.txt. I know I created car.jpg. I know I created brand new dir link.txt. Okay, as far as I know, and I think a new file.txt. Okay, so I think that's all I've created in the last 4 days. Okay. Who the fuck is calling to the house? Jesus Christ, some people have no fucking cop on. Sorry, someone called at the house and they shouldn't be. So I should distance in me whole. Anyway, so we are going to put in our path. The original. Okay. Right. So we are going to go files dot find. So files dot find. I'm going to put in, we're going to start at path. We're going to go to a max depth of 5. Okay, I don't go beyond that as far as I know. Okay. Now I am going to put in a by predicate here. Okay. I'm not going to bother putting no link or follow links or that sort of shit. So we're not going to follow links. Okay, and I'll call it the matcher, but this is the by predicate. Okay, so this guy here, that is the path. The 5 is the maximum depth. It's going to go to a maximum depth of 5. Now this is the by predicate part. So this is the complicated part. Now, so what we're going to put in here is, so I'll put this on a separate line. Okay, so I'm going to put in a by predicate here. So, and by predicate takes in 2 arguments. Now, it's going to take in the path, call it P, okay? And I don't know if we did these already, but there's something called basic file attributes. We did, didn't we? I think we did. These are the basic attributes of the file, okay? Now you can get when so we can either return, is that not the correct one? Let me just see. Okay, that should be correct. Let me just see. It's basic file attributes att see. Okay, why is that not working right? Yeah. Okay, let me just see. Basic file attributes. This should be correct. Okay, I'll have to pause this again because this is, sorry about that. Anyway, so files.path 5. Okay, so file, it takes by predicate. Okay, now it takes a special type by predicate. Okay, now just to make absolutely sure of this before I go any further, I just want to try it here again. All right, so the find method takes a by predicate, or it's a special type of by predicate. It's a by predicate that has to have a path and a basic file attribute. Now, a basic file attribute, you can find things about when it was created. When we did these before, I think it was in 9.3. Okay, geez, that seems like a long time ago. So you could also do things like add creation time. Is it a directory? Is it other? Is it a regular file? Is it a symbolic link? The last access time, the last modified time, size, and we also have creation time. Okay, so we're checking. So when you're using find, it has to take a path and has to search for basic file attributes. Okay, now, so this first one we're going to do, so paths.find, path 5 to level 5. So it's all of these, so C original to 5 levels. Okay, it takes path, it takes 2 arguments, which is path P, which is each one of the paths contained within inside C original. Okay, and it also takes basic file attributes. Now, basic file attributes is an object that holds metadata about that path. Okay, so it's so basic file attributes, it's the metadata about, sorry, I stand corrected, about each of the paths. Okay, so this is each of the paths contained within C original, including C original. Okay, basic file attributes, they are metadata about each one of those paths. Metadata, as I've already said, when it was created, when it was last accessed, is it a symbolic link, so on and so forth. Okay, it's a single object that contains all those details about each one of the paths. Okay, now, so first to go, so return files is directory. So it's going to check each path, is it a directory? And it's going to check, is it not a directory? So if it's not a directory, so if it's not a directory, so if it's not a directory, it's a file. So return true if a file and, so this one here, as dot creation time. Okay, now that will get you the time when the file was created. Okay, but it will give it in a local date time. You know, you can do other methods, but this, I seem to remember, the easiest way to do it. So a.creation time to time unit.seconds. So what does that convert to? This converts the creation time of files to the amount of seconds since the 1st of January 1970. Okay, so if it's greater than the time 3 days ago, yeah, if it's greater than the time 3 days ago, then the file was created in the last 3 days. And the files that were created in the last 3 days is C original brand new dr.txt, a JPEG, TXT, and country text.txt. Okay, so them were the only 3 files that were created in the last 3 days. Now, I also did another one. I only want to get the text files. So this just gets text files only. This one, there's all the text files. We don't see car.jpg. So if I take out this one, and this one instead, we're going to see an extra file, car.jpg. Now you can use this find, but personally, I prefer to use walk and filter. Okay, because you can use basic file attributes as well of each one of the objects inside filter. All right, so it's up to yourself if you want to use it, but personally I prefer to use walk and filter. Okay, now so that is find. I'm going to go to ex3 is the next one. Now, so the next method we're going to do is, now these are all variations really on walk. That's the best way to describe it. Next one I'm going to do is static void ex3. This is list. Okay, so it's correct. It's files.list. Okay, so what does this do? This listing directory contents. And again, you could use a walk to use this. All right, because if you walk a directory with, let's say, depth of 1, that will just give you all the files inside that directory. If you just go walking, it's going to list all of the directories and all of the files inside that directory. If you go walk with the filter that only allows directories, it's just going to show the directories. If you go walk the filter that shows only files, then it's going to show you just the files. So they all do the same. These files.find and files.list, you could also use walk with the filter. All right, just another way of doing things. So, so I'm going to create a folder to start off with. I'm going to go in here to original, and I'm going to go here. I'm going to create a folder. I'm going to call this folder, what did I call it? Folder A, imaginatively. Okay, now inside folder A, I'm going to have one file only. So it's only going to be one file inside here. And I'm going to call this new text document, and I'm going to call it folder a.txt. Okay, and I'll just put in a bit of folder a.txt file in folder a directory. Fine. Okay. Take that lad out of the way for a minute. Now, so we okay, let me just see. Can we pause for a minute here again? So resuming it again. Sorry about that. So in the original folder, we create a new folder called folder A. And inside that, we have one file. Okay. And inside that, we have one folder called folder B. And inside that, there is only one file called folder B file.txt. Okay. Now, I'm going to show you the difference between list and walk. I still prefer walk. I don't care what they say. I think walk is easier. All right. But that's neither here nor there. All right. So if we go, so the original path, we're going to go here. So path is equal to paths.get. I'm going to go C original. Always check to make sure that it exists. So files.exists path. That should, so it's ex3 main examples.ex3. And we'll just get this one finished today, but I won't get apologies for not being able to do more today, but such is the joys of the COVID nation. Okay, so that's coming up as false. Okay, so it is not. So what did I call it? It's the original folder A. I have it here. That's folder A. So what did I do wrong there? folder. Okay, I don't know what I did wrong there now, but it's the URI, so yeah, who knows? Who gives a shit? Okay, so it exists. Okay, fine. Now, so we put inside a try catch back. Try. Now, so we are going to search for only files. Okay, so if we go files.list, so list. So we are going to search this path. Right? And if I just did it like that, so what that does is, now, first of all, lists only searches one level. Okay, so this will only list files and folders of it will not list any subfolders. Okay, it will not list any subfolders or files of that subfolder. Sorry, it will list the it will only list the files and folders of folder A. So it'll list folder B and folder A.txt. So it will not list the contents of any subfolders or files contained within a subfolder. So it only searches at level 1. Okay, this is the equivalent of using walk. So of files.walk path 1. Okay, so it's the exact same as file.walk path 1. Now, why wouldn't you use this? I don't know. I think walking is just easier to use. So let's just say we only want to print, we want to use files.list. So using list to only show files. Okay, so we got files.list dot, and we've got filter. So what we do is it takes in a path and it returns files that is directory. It's not a directory, P. So if it's not a directory, I'm going to go dot each. So I'll put this over lines. So there is only the files. Okay, so files.list filter p.directory. All right. Now, if you want to display the same thing by using walk, if I use walk, let's just say files.walk. I don't say to what depth. Okay, dot for each. So I'm going to say here using walk. So what that does is that displays everything. Displays all of the subfolders. So if we only want to display files, so this one here, using walk to display only files of so we would go files.walk level 1 dot filter. Predicate takes in a P. So we say files dot is directory, and we will say P. for each. Now, is that any easier than list? I don't know. It's definitely easier than fucking this thing up here. All right. I think find is a hugely unwieldy pile of shit. All right. So anything you do with find, you can also do with walk. All right. Using walk display only files C original folder A. So this is to one depth level 1. Now, if you just use walk, without a depth, it will display, or it will pick all files, folders, subfolders. Okay. If you use walk with the depth, with a max depth level of 1, you get the same results as if you use list. Okay, so list only shows the immediate file or immediate folder. But walk also does the same thing if you just go path 1. Okay, you should be able to use something like this with a filter. Okay. Yeah, you should be able to. I'd have to think that. I'd have to think that. Yeah, I'd have to think about that a bit. You should be able to use this as well with walk. I have just one more to do here. Now it's okay. I'm gonna have to wait till tomorrow, I'm afraid, to do this last bit here. So again, apologies, it's so short again today. It's just that cooking dinners and doing various shit, and because there's a few of us living together, there is houses, let's say my sister's up the road, and you know, the sister's just up across the field. So, and they're all off work like me, so, and they're all basically, they're all cocooning, you could say, as well. So they visit here regular, so it's very hard to get things done a lot of the time. Okay, so hopefully I'll get more done tomorrow. Can't guarantee it, but hopefully we'll get more done tomorrow. All right, but we'll definitely get section 9.4 finished tomorrow, and that will be then chapter 9 finished, and then we just have chapter 10 left to do, which is databases. Okay, yeah, databases, the grant. All right, some of you won't be that familiar with databases. You don't need to know databases to do this chapter, so don't worry about that. But we will be doing some basic database operations as well. You'll need to download something called XAMPP. I'll do a video of what you need to download anyway, so don't worry about that. But yeah, we will get 9.4 and probably start on chapter 10 tomorrow as well. On chapter 10, start on chapter 10, I'll be detailing what you need to do to get set up. Okay, you're basically setting up your own machine as a database server. Some of you who have done the MySQL course with me before will know how to do that, but I will do a video of how to do it anyway. Okay, so with that, folks, then I shall see you with another video tomorrow again. Okay, good luck. Bye.